dos, uno. Hi everyone, welcome back to our channel, Becoming a ROS Developer here at The Construct. My name is Rodrigo, and today we have a presentation from one of our students who has completed the course ROS2 Basics Python. It's one of our courses that offers a certificate of completion, and how you get this certificate is by completing a real robot project in which you program a real robot here at The Construct. So I'm excited to see what our student Alberto has for us today. Hello, Alberto, how are you?
Hello, nice to meet you.
Nice to meet you too. And yeah, like I said, I'm excited to see what you've done with your project. So whenever you want, you can start sharing your screen and just tell us what you've done with the project.
Okay, can you see the screen?
Yes, I can see the screen. I can see the real robot and a terminal.
Okay, yes, here I have the launch file ready to go. And here's the real-time robot. I'll start it. Once I start it, the robot will start, you can see, looking for the closest wall. It's right now spinning towards it. And now it's getting closer. Once it's close enough, it will start spinning again and aligning with the wall.
Okay, yeah.
That's finished. And now the robot is doing his main task, which is following the wall. And here we can see the feedback that an action server is giving to us, which is the current distance made by the robot.
Mm-hmm.
The robot will keep following the wall until it has completed one lap. Okay. Once that main task has been made, an action server will return as a result or as a response all the odometry points, which represents where the positions where the robot has been during that lap.
Great. So then, if I understand correctly, it's 3 main sections, right?
Exactly, 3 main sections. The first section is like the main script, where all the wall following logic is, and where the different clients are too. Then we have another script, I'll show it later, that basically finds the closest wall to the initial position of the robot. And
that's what we saw in the beginning, right?
What we saw in the beginning. And the last part is what we are looking right now at the terminal, which is basically the feedback that it's giving to us.
I see.
And the list with the odometry points.
Okay, very clear. And so I assume when this is done, the robot will stop, or will it continue to?
Initially in my program, the robot continued making the. Okay, so the lap finished, the robot stopped.
Okay, it stopped.
Initially it continued just following the wall, but I made this stop so it could be more clear that the one lap was completed.
Yeah, in reality it doesn't matter, but yes, this way it kind of closes everything up. Great. So that's
here it is, the
exactly
entire list.
What the project asked to do. We can see there the list of the points of. So this isn't the whole distance, because we saw the whole distance before.
We see here that the current distance, and I also printed the total distance, which are approximately 6 meters.
Awesome. Well, perfectly clear, Alberto. So now, if you would just sort of give us an overview of how you've done this. Great. Yes.
Okay. As I told before, I've made 3 scripts. The wall following script, which is the main one, and then the wall finder script and the odom recorder.
Okay, so you have 3 scripts. And then in the beginning you said, sorry, I'm interrupting you, just to get a clearer sense. You said there was a launch file. What did you mean by that?
Launch file. Okay. we have here the main launch file, which is an executable that makes the 3 different scripts start working.
Great. That was my question. Yes, perfect.
So I don't have to make each one start working individually. I
Right.
make a launch file that makes everyone at the same time start working. So once this has been seen, okay, this is the wall following script. The main one, as I said before, is a wall follow class, which is a subtype of a node class that has like every class a constructor function where the service client configuration and the action client configuration takes place, and where I initialize some variables, as we can see here. After that constructor function, we can see a function to call the service server, which is named initialize position, and other functions to manage the communication with the action server. The first one, initialize autumn recorder, is the function to send the goal to the action server, what I want to do. Here, I'll handle the response to that goal. If the action server says, okay, everything's okay, I'll start, it will say that the goal has been accepted. Otherwise, it will reject that goal. And here I have these 2 functions, which are callbacks to manage the result that the action server gives, or the feedback, as we saw the current distance that the robot had made. After the service server, which is the task to find the closest wall, what we saw in the beginning, once that has been made, I've created this function to initialize all other communications components which are needed to the tags to follow in the wall, which is a publisher that publishes velocities that the robot has to follow. Here I have a subscriber and a timer, which calls a motion callback. We can see here below.
Right.
That represents the main logic of the entire task. Here we have the laser callback. It's the callback where we get the information about the distance that the robot has a laser on its top that shows the distance between objects surrounding the robot. And here we can get that information.
So you get the 4 main points.
The 4 main points, exactly.
Okay.
And here we have the main motion callback, which has logic to the robot, for the robot to getting away or closer to the wall, or turning in corners, basically to follow the wall.
I see.
And this is just the main part of the script, which makes everything work. Here I create the node. I initialize the position. This is calling the service server, as I told before. This while loop basically checks if that service server is finished. Once it's finished, we initialize the action server. We also initialize the other communications.
What do you mean by the other communications? The subscriber and the publisher?
Yes, exactly here. Communications, the for the main logic to work.
Yeah.
And here I basically spin the robot, spin the node, which means which means basically that the node will continually check for the communications that are active, and will make the robot follow the wall. Okay, that was the main script. Not the main script, but one of the 3 parts. Here I have the wall finder, which is the service server, the part that looks for the closest wall and gets the robot closer to it. As before, here we have another constructor function where I create the service server, and which is here below, and the publisher and subscriber needed to, in this case, read also from the laser, which we can see here below.
Yeah.
And Okay, yeah.
Which we
And
can
the
see here.
publisher is to, again, publish some velocities that the robot has to follow.
Okay.
Here have, as I told before, the laser callback, and here we have the find wall callback, which is basically the function that executes once the service server has been called.
Right.
Okay, this shows some info, so we know where we are right now. And okay, and here we enter the main logic, which structure is the one of a state machine.
Okay.
That means that I've divided all the tasks in different states. The first one is searching the wall, looking which distance that the laser gives is the smallest one.
I'm assuming stage 6 is the last one.
State 6, yeah, it's the last one. It isn't in actual state, but just the condition to getting out of the while loop.
Right.
The last state is the 5th one.
Okay. And then
once
exactly you pass it to 6, and then okay.
And everything's finished. Yeah, this is the task: looking for the wall, rotating towards the wall, moving, stop moving, rotating again, and when it's aligned, it will get out. This is the main part, again, to make everything work. I spin basically the node, and everything works like it should.
All right. And this
finally,
will be similar, right?
Yeah, that's pretty similar. And finally, the autumn recorded script, which is basically the, in this case, the action server. We have, this is a node called my action server. We have a constructor function like before, where I create the action server. And the subscriber I need, in this case, to read information from the odometry sensor from the robot, which basically tells the position and the orientation of the robot in each instance. In this case, I just read the X and Y position. I don't need anything else. Okay, as I just told, here we have the odometry callback. And after that, we have the action service callback, which is like before, the function that executes once the action server is called. It basically just records the odom data that the robot provides.
It starts adding
it. Sorry?
And it starts adding it, I'm assuming, for that
exactly in this list, in this odometry list. Each second, it is everything. Yes, this saves the positions of the robot each second. So we just don't have a super large list.
Yeah.
Okay, here we have the main while loop where everything happens, which is it saves the current odometry position, gives the current distance as feedback, and it also computes if a lap has been completed.
Oh, I see.
These two last things, where you compute two values, actually occur here in the feedback function, which is called from this while loop. In this while loop, you call the feedback function, which computes these three distances. I'll explain them. The last distance is the distance made in the last second by the robot, which is every second added to the total distance. This total distance starts as 0, so it will adding that tiny distance. Okay, and the start distance, as we can see here, is just the distance between the current position and the initial position. This value will be used to know if a lap has been made. If that start distance is very close, we know that the robot is again where it started. And yeah, that's all. Nothing else to explain. Here we have the main function, which is pretty similar to the other ones.
I see.
Just spin the node and.
All right. Well, awesome. Well, first of all, I was going to ask you to stop sharing your screen, but let's keep it here because I have some questions. Congratulations, Alberto. Really nice project. Really clear. Looks like you've worked with Python in the past because it's a very well structured code, and I really like how you are using, especially the action callbacks, because it really shows that you've understood the difference, for example, between a service and an action. Because I see here that you're using things for the feedback callback, you have result callback and the wall finder. You have everything very separated, as opposed to you could have just achieved everything with just the normal action callback, and the fact that you're using all this shows that you've understood it correctly. So I think that's my my sort of favorite part about your project. And I just want to ask you a couple of things, if that's okay.
Okay.
So in both the wall finder and the autumn recorder, you have mutually exclusive callback groups. While in the wall following Python, I don't think you do.
No, I don't.
What is the reason for that? Why? So for someone that doesn't know anything about ROS2 callbacks with Python, why did you add those mutually exclusive callback groups in those two and not in the main wall following program?
Okay, so the main reason is because as a default setting in ROS2, the nodes will just have one thread, which is basically one. We can see that as one person doing the tasks.
Yes.
So one person receives a callback. Okay, so the person is told that he has to go to a certain callback to do the task. He goes there, completes the task, and comes back. But if we give that person that same thread two callbacks at the same time, it will complete one callback, come back, and then go to the other task, complete the callback, and also come back. So when we need in a code that the robots or the task that two callbacks are made at the same time, what we need is two threads, or we can tell it as two different workers that go at the same time, each one at a different task. So what is a mutually exclusive group in a mutually exclusive group, callback group? In ROS2, each callback is attached to a callback group.
Yeah.
By default, these are, I think, if you don't tell any, here you can see, for example, a subscriber. Every time the subscriber gets new info, it goes to the callback here, meal laser callback, and it's group number 2. Well, by default, if I don't write here anything, ROS will attach the subscriber to a same group. All the callbacks will be in just one group, and we will have just one thread, which basically means that one callback will be completed at a time, not at the same time.
And that means there will be a blocking situation, because
Exactly.
we have this callback and then we have another callback in this in this program, correct?
Correct. Exactly. So in the wall finder script and then in the autumn recorder script occurs this, where more than one callback wants to be executed at the same time.
Right.
So I decided to basically define two different groups, two different mutually exclusive callback groups, and attach each callback to that group.
Great.
And after that, here I had to create an executor with two threads, two workers, as I explained before, that can process those two different callbacks at the same time.
Understood. But I asked this question for a reason, and it's because I saw that in your wall following program, you probably have a subscriber to the scan topic, or not, or is that not correct?
Let me see.
Because I saw you also
Yes.
have a timer function which calls
Yes,
for a
but
callback.
I have here here I have it. Where is it?
Oh, actually, you're not subscribed. Yes, I can see
Yes,
it
I'm
right
subscribed
there.
here to the laser
Yes.
callback, exactly. Yeah, I'm
So how does that work? That you're doing a timer callback and it's not blocking your scan callback in this one?
because I'm reading continually I'm sorry, I didn't understand it. Could you repeat, please?
So you said that the reason why we have a mutually exclusive callback group in the other two scripts is because basically you have more than one callback, and
Yes.
that will prevent. So they will block each other if you have one thread only, one group. But in this case, you also have two callback groups. I'm
Yes,
sorry,
but
you also have two callback functions, but you don't have a
exactly.
mutually exclusive. I was wondering why that is.
In this case, because these these two callbacks execute extremely fast.
I'd say, what's the timer period there? That's half
The
a
timer
second?
period is half a second
Okay.
here. So I'm basically constantly checking the values that the laser gives, and that doesn't need basically any time. And each half a second, I give the robot a command, so it changes its velocity. But both of these are two very fast tasks. So even if two come at the same time, imagine that the laser callback and the motion callback want to be executed at the same time, and the laser callback goes first. It will very fast check the values of the laser, and then it will instantly go to the motion callback, which doesn't have any loops. It will just iterate once.
Okay. I understand
He
what you're saying, but they are just as fast in the in the other two, right?
in the other two, they aren't so fast. For example,
Because
here,
you only call the action once, or you only call the
exactly, you call only the service setter once. Here is a while loop, which is the main while loop with a state machine, which basically blocks, uh,
yes, that
which
blocks it
basically
completely until it's done. But
exactly blocks completely until it's
yeah,
done.
I think it's important to touch on this, and I might be also misreading what you're saying as well, but there's also, I think, a different reason why, in theory, you are blocking each other in the main while following. But if you check on the timer period, you have zero point 0.5 seconds for the timer period. That means every time the timer runs, that's 2 hertz, right? That's 0.5. It's 2 hertz. It's twice a second.
Yes,
And
exactly.
the subscribers usually have a period, like a callback. They have a default. You can modify it at the end where you're defining that subscription.
Yes,
But I
here.
think the normal one is 10 hertz. So that means you get 10 times a second. And you get 2 times a second. So there's not really that much overlap that would be, for example, in the action callback, where the
Exactly.
callback for the action is going to be, I don't know, like 2 minutes, because that's how long it takes the robot to go around. So you've actually received 4 different, I don't know if it's 4, but 10 hertz versus 2 hertz difference. You've already received 4 more values from the laser. So that means you have updated values in this motion callback. So it knows what to do. But I would argue that, in fact, it's missing the latest one. And maybe that leads to a little bit of an extra, swing in the movement, because it didn't receive. If you had a timer, a good way to test this is if you increase the timer of the the period of the timer, right? So if you put
Yeah.
that at, I don't know, 20 hertz, my guess is that this behavior would be completely different, and that would be the reason why. Fortunately, this works really well because of that difference, in my opinion, and it's a good solution. So my philosophy is always, don't fix a problem until you run into it, right?
Yeah, exactly.
And so if you're trying to create the perfect program, you could do 1,000 more things to fix this. But I think it's really important especially for getting started, to understand how these callbacks are functioning. So that's why I asked that. But I was also asking to make sure you understood, and clearly you have. So that is my sort of the only thing that I think is worth mentioning, because again, I think you really understood the main 3 points of ROS Basics, and it shows here. And then the last comment I wanted to touch on is on that launch file. And you probably, if you get more into it, more into ROS, you'll see that ROS2 now has a great function, which is a lifecycle manager, which in this case, you would include it into this launch file. And in this case, it wouldn't matter because you just want to launch everything all together. But this lifecycle manager allows you to sort of launch nodes and wait in a consecutive order, so they don't get hung up waiting for something, or they don't. You can configure them at runtime, modify them at runtime, bring them down, but not completely kill them. And it's a really powerful tool. So I recommend you look into what the Lifecycle Manager does for you in ROS2, which I think is a great addition versus ROS1.
That's a great tool. I've never heard of it.
Yes. And I mean, other than that, this is it. Do you mind stopping sharing your screen here so we can
Of course.
sort of say goodbye here?
How do I? Here.
Probably an X or something. There we go. There we go. Let me just fix the screen. Yes. Anyways, yeah, congratulations, Alberto. Really, really nice project. And I'm glad we got to talk about those callback groups, because in my opinion, they're the trickiest ones to kind of conceptualize in your head. And I'm glad that you've done a project that is clear, simple, and gets to the point, which at the end of the day is the point of these presentations. So congratulations, Alberto.
Thank you very much.
And yeah, whoever else that is watching, this is your opportunity to do what Alberto did here and take one of our courses that offer a project with the real robot, in which we will be able to offer you a certificate, because we can guarantee that, like Alberto, you have taken in the learnings of our course. So I invite everyone to do the same. And Alberto, thank you very much, and we'll see you in the next one, hopefully.
Thank you.
All right, everyone. Bye-bye. See you next time. Perfecto.